Alrighty, I'm back for this 2007 Dodge Ram 2500 HD with the 6.7. So this is the remanufactured ECM we got, but you'd have to watch the other parts of the video. But I think it was part 6. We had an issue with the actual. Let me find it here. Got stuff everywhere. The actual fuel actuator control. We had 12 volts on one of these lines and the other one we didn't, and the service data said that we should have 6 volts with key on engine off, and then it goes to 3 volts on the driver's side, and I believe 0 volts on the return side. If I remember right, we had 12 volts on the return side and nothing on the driver's side. So anyways, we want to bench check it because I don't think it's a wiring thing. I think there's something wrong with this computer that we got used. So what I got going on here is I got my OBD breakout box and I got a power supply hooked up. Because this computer is fused by a 30 amp fuse. So I have that power supply hooked up. It goes up to 100 amps. It's not going to draw 100 amps. It'll draw what it needs. So red, I got my constant battery power in my ignition, and then black I got my ground. These two leads here are for these two wires here for the control driver and can return for the fuel control actuator, FCA. Then I got my other two lines going to my breakout box, 120 ohm resistor in there, 120 ohm resistor in here. So it terminates, you get 60 ohms across the bus. I measured that. I did this in another video, the same truck, different part of the series, but that's all good. I got a ground piggybacked off of this going to my breakout box so I can have my VCI plugged in so I can hook up my scan tool. I did this in another video with the same truck. I said in this video series, I just can't remember what part it was, but that's how we proved that the vehicle ECM was bad. One of the many ways we proved it. So I got power and grounds on, everything hooked up. First thing I noticed, which is nice, is we can actually, if you remember from the other parts, the old ECM, we could never read codes. Actually, we could read codes, there was just no codes in there. Well, now there's a ton of codes in here because, well, it's not hooked up to the vehicle, as expected. Go to live data. Before we couldn't read live data on the old one. In the truck, out of the truck, we are communicating. But I'll pull up live data just to prove that I can read it. So that's why this truck runs and good starts now. It needed a new ECM, but this is a reman one. Like I said, the dealer wanted $3,600 just for the ECM. Got this reman one from somewhere in Fort Lauderdale, Florida for $700. But honestly, the quality of it, I'm not real happy. Like the way they painted it, like these big ass screws, the original screws are Torx. Did they test all this? I don't know. It just seems like something's not right. See the CAN bus lights flashing, 6 and 14 on the pins. Anyways, here's all of our live data. So that's good. Go to ECU information. Now I don't really need to do this for this part of the video. We proved this on the truck, but since we're here, my main reason for filming this part 7 is to check these wires coming out, because this will eliminate all of the actual wiring on the truck. Yeah, so ECU information. 2007. There's your VIN original, the new one. So the truck or the ECM's communicating fine. So we go to special function. We go to, we're not going to write the VIN, we're just going to read it. So we're just simulating it's like in the truck, it just doesn't have all these sensors hooked up. I wanted to eliminate that harness because at part 6 I was thinking I had to short the voltage or something. So if I go to check PCM VIN, you can use this to read and write. Okay, we're just going to read it, not write it. The VIN is valid. So we're going to exit out of that. So that tells us, well, that's all good. But before we check these pins, let me hook up the oscilloscope to this CAN bus, because before we had a really crappy CAN bus, high and low wave. Since we're here, I just want to prove it on video. This is the one, remember we originally I thought it was the TIPM that was bad, and then the ECM, a bunch of different stuff, troubleshooting. TIPM's fine, it's a bad ECM. Now we got a good one, but there's still part of this ECM that I believe is bad, and I think it's the circuit. whether it's a transistor or MOSFET transistor in here, switching it, because we're not getting the right results. I'm going to hook up my oscilloscope to CAN high and CAN low next. Alright, so to do my CAN bus, I isolated the breakout box because of ground issues. Or not grounding, because I don't have everything power and ground from the same source. I'm using that and that. So to get a nice clean signal, pin 6 and 14, 120 ohm resistor, 120 ohm in here, there, across the bus you get 60. I'm scoped there. Well, I was grounded there. Grounded there, scope there, powered on with the power supply. Roughly alternator voltage 14.3, 14.4. There's our CAN bus. That's CAN low. Now let's look at CAN high. Already we're in CAN high. So if you look, I mean, you'd have to zoom in, but there's some noise in there. I had to put a filter in there. But if I zoom in, go to the bottom there, 2.5. Go to the top, 3.6, 3.5. So there's a lot of noise in there. I don't know if that's my setup, but you know, the same, you gotta, that's why I'm using the same power source. So CAN bus, CAN high, CAN low is all good. So now what I want to do is check those 2 pins, get this reconfigured up with the breakout box, check those 2 pins and see what I have from there. All right, so same thing, I just got power and ground, leaving the breakout box out. My 120 ohm resistor in there parallel to get 60. 120, 120, parallel, you get 60. So here's my 2 leads here. That's pins 10 and 30 for the ECM. Because it's 10 and 30, you can see the little marks there, because we got the 6, 7. So if you look at the schematics, it shows that. This is pin 10, this is pin 30. All right, so what I have now is my ground. Just going to a ground for my power supply, and then my power, I just use these banana clips. Not banana clips, 4mm bananas from my power time. Let me start over. Ground, COM, going to my ground. The positive lead going to pin 10, which is return, and it should be no voltage. Well, I got 13.9, 14 volts, right? So that's what I had on the truck, key on engine off. You know, I had a little bit less because I just have battery voltage. I got this dialed up a little bit, the power supply, but I shouldn't have voltage on that pin at all. It should be a ground. So that tells me the computer is indeed bad. Not the whole computer, that circuit in there. So now let me go to pin 30. It should be 6 volts right away, and then it should go down to 3. But I don't think I'm gonna have any voltage. Let's take a look. Alrighty, I'm on pin 30. Should go to 6 and then go to 3. 0, nothing. That tells me this computer is absolutely bad. So let me show you for service data why I believe that is bad. Alright, so service data here. We talked about this in part 6. But basically, so the field control actuator, FCA, is an electronically controlled solenoid valve. The ECM provides a pulse width modulated driver circuit and a ground circuit to the FCA. The ECM varies the current to this valve to provide the correct fuel flow to the high pressure pump based upon operating conditions. It's normally, the FCA is a normally open valve. High circuit resistance may cause fuel pressure to be higher than commanded at light loads. Although this is primary electrical diagnostic, yeah, check fuel lines, blah, blah, blah. And that's when his ETC light comes on, his middle light comes on. So, when is it set? The ECM detects the discrepancy between the pulse width modulated signal supplied to the electronic field control actuator and the PWM pulse width modulated return from the electronic field control actuator. Talks about field control actuator driver circuit short to voltage, return actuator return short to voltage. Well, yeah, in the computer it seems like that's what it is. And then, so it seems like the return is shorted to voltage in the computer, and the actuator driver's shorted to ground. But what it tells you, the K365 FCA driver circuit will read approximately 6 volts at initial key on and then drop to 3 volts. So the K365 circuit is this one. It says it should go to 6 and then eventually 3. Well, we're not getting any of that. We're getting 0 volts there and 12 volts on the other side. So that's not right at all. So I believe that the computer driver return circuit in there is bad. The computer's fine, but just that one little circuit in here, they gave us a bad computer. So they need to give us, you got to return this computer and give us a new computer to make sure that we are good to go. Because it tells you, well, let me just pull the diagram over here instead of walking back and forth. So what it shows you, field control K366. So it shows K366 field control actuator return circuit shorted the voltage. So K366 is this one. That's the return. That's where we had voltage. We're not supposed to. So it tells you, measure the voltage of the K366 circuit at the harness connector, which we're doing right at the ECM. The K366 return should not have voltage present. Is there voltage present? Yes. Repair to short the voltage in the return circuit. Well, it's not the wiring in the truck that's bad. It's the computer that's shorted. So absolutely, 100%, this computer has a bad circuit in it. You either return it, get a different one, get the new one put in. So we just got to send this one back. Well, since we're here, we'll do one more test. What I'm doing now, got the vehicle communicating, or the ECM communicating, but I got my oscilloscope hooked up. I'm on pin 30, which is the, I don't even know what I did with the paper now. Oh, here it is. Pin 30 is the driver. That's where you should have 6, and then right now we should have 3 volts. I'm hooked up to it. I'm not hurting that pin. Looks like it. It's not. It's just literally laying there. This is a very soft lead. So I'm on pin 30. Should have 6 volts. On the scope, we got 0 on a 20 volt scale. But if you zoom in, there's some kind of stuff going on, right? But it should be up in here. So now let me go to the other one. Now I'm on pin 10. The return should have no voltage. And we got 14 volts. Same thing we got on the multimeter, right? But just shown on the scope. That's not right at all. Well, I did do some high pressure common rail duty cycle output, but none of this stuff is, none of it's changing on the scope. I'm on the driver's side now. None of this stuff's changing. It's just grounded. I put it on the other one here. It's not fun doing this by yourself. Trying to film. That's the return. Should have no voltage, but I do, just like before. So yeah, something shorted inside this computer, which is, it's basically you just got a constant power and ground, which is not right at all. And I try to do these high pressure field system tests, but you can't do it because of, you have to have it running. So obviously it's not running. So, all right, so what I'm gonna do now is, you know, if I got power and ground, because that's what I have a test light hooked up, which it's not turning on. So I got the ground side going into one side and the other side, I'm just doing it, and I know the test light works, but I just checked it on the car battery and on this power supply, but I have nothing lighting up. So that tells me this is an LED test light. No, it's not a LED, it's an incandescent, sorry. It's an incandescent test light, but it's not lighting up. So it tells me it's not drawing that many amps, right? So, at all. So it doesn't light up that incandescent test light. Back on there, you can see a change in voltage. You can see that on the scope on the waveform too earlier. But there's our battery voltage, which we're not supposed to have. And then this one we're supposed to have, you know, 6 and then 3, should be at 3 volts, which we got nothing. So, computer's bad. That part of the computer's bad. It's a good computer except that one circuit, which makes sense because this guy never had this problem before until we get this computer. Now it runs, it starts, but it's not controlling the FCA, the field control actuator, because this circuit inside this computer is bad. So we got to send it back in. Hopefully they warranty it out. I think there's like a 30-day return policy and a year warranty or something like that. So we're only into this, not even a week yet. So, well, about a week now. So we can send it back and then get another one and put it in and hopefully finalize this video series. So that'll be it for now. Oh, and one more thing before I go. These 2 pins here, the return and the driver. I powered everything down. Why? And then I had the test light in there and I left it in there and I turned the power back on. I tried to cycle it a few times, like turning the key on, engine off. The test light never came on. The incandescent test light never came on. So just got to get a different computer.